Okay, let's take a look at equivalent fractions. First of all, just a little bit of a warm-up. What is this following? This following is a fraction. And it's composed of two parts. The top part is the numerator, so that's what we want to call it, not the top. The bottom, where the b is the denominator. Okay, so from here on out, we want to use numerator and denominator. Now, let's move on down. They do say b cannot be 0. That's with an exclamation point, and that's an important fact. You cannot have 0 in the denominator. And we talked about a couple ways to remembering it. One way is the trust game from gym class. You wouldn't want to fall back into an empty area. So if here is the bleachers, and you have 3 people up here, but 0 people down here to catch you, 3 over 0 equals splat. Bad news. So that's one way to remember that you should not have 0 in the denominator, or it's going to give you an error. Another way that's a lot more mathematically sound is to think about what we know. So for instance, 12 divided by 3 is 4, and we can check that by doing the inverse of divide, which is to multiply. If 12 divided by 3 is 4, isn't it true that 4 times 3 is 12? And it is. And that's going to work for anything. 10 divided by 2 is 5. 5 times 2 is 10. That's really how you learn your multiplying and dividing principles. Well, if we take into account, let's say we put 0 in the denominator, 3 divided by 0, and we don't remember, so we just write 0. Well, let's check it. 0 times 0, is that 3? No. Okay, so even if you forget, I hope you remember this little trick so that you can double check and be like, oh, that's right, you can't divide by 0. Okay? So that's an important rule. Now let's take a look down here, and we're talking about fractions. That's why we had to bring it to the point. The directions say to write equivalent fractions, multiply or divide the numerator and denominator by the same non-zero number. So here they do it with algebra. They multiply a times c and b times c, and they get an equivalent fraction. Or you can divide a times c and b times c, and you get an equivalent fraction. Same with numbers. If we start with 1/3, if I multiply numerator and denominator by 2, I get 1 times 2 is 2, 3 times 2 is 6. This is equivalent to this. 1/3 is the same as 2/6. And it would be like, oops, pretend that's a pizza. So we have, we'll cut this so we have 6 pieces. 1, 2, 3, 4, 5, 6. Now, I could either think of it as 3 big pieces, that's like that. So 1, 2, 3. And then say, well, I want 1/3 of this pizza, 1 out of 3, with these 3 big pieces. Or, that's the same as saying 2/6, because there's 2 of all 6 of them cut out. So they are equivalent. They mean the same amount, but they're written differently. And lastly, the reason you're allowed to do this is because you're multiplying by 2 over 2. 2 over 2 is the same as just 1. Anything over itself cancels out by 1. So essentially, you're not really multiplying by any new value, you're just multiplying by 1 and writing it differently. So that's why you're allowed to do this. And same goes with dividing. Okay, so let's take a look at the next page. And we're going to go ahead and there we go. Write 2 fractions that are equivalent to the following. So they want us to multiply or divide the numerator and denominator by the same non-zero number. So just to practice, I'm going to multiply both by 2, and I get 10 over 20. These are equivalent fractions. I could also have divided by 5, because they want us to multiply or divide, so we'll do both. 5 divided by 5 is 1, 10 divided by 5 is 2. So we have shown here that 1/2 is the same as 5/10, is the same as 10/20. These are all equivalent, okay? We'll do one more. It says multiply or divide. I'm going to pick 3 to multiply both of these by, and I get 18 over 27. If I go the other way, I could divide both of them by 3, because 3 is actually a factor to both of them, and I'm going to get 2/3. So 2/3 is equivalent to 6/9 is equivalent to 18/27. They all say exactly the same thing, and there are really no there's not one specific right answer for these kind of problems, but there definitely are things that are not right. So you want to make sure you're careful with your multiplying and dividing. We're going to skip example 1 you try because it's the same thing. And like I said, there aren't specific one right answer. So it depends on what numbers you would choose. But simplest form. A number is in simplest form when its numerator and denominator are relatively prime. So there's 2 easy steps here we're going to follow. And you may be able to do some of this in your head, but if you can't, this is really how you want to think about it. And the better you get at it, you'll do this without even going through the steps. You'll just know what to do. But 4 and 14. So I want to think about what goes into 4 and 14. And I can go back to Euclid's method. 2 goes into both of them. And now I can say, okay, so my GCF is 2. So that's going to be the number I first determine the GCF. Now divide both numerator and denominator by that number. So I'm going to divide by 2, and I get 2/7. So my fraction in simplest form is 2/7. And look at this, guys. 2/7. Aha. So Euclid tells you the GCF on the left and the equivalent fraction, simplified fraction on the bottom. 27 and 42. 27 and 42. What goes into both of these? Well, 3 does. 3 goes into 27 9 times. 3 goes into 42 14 times. So we can tell already that our simplified fraction is going to be 9/14. So we're going to, but if we were not to know that, we would divide both by 3. 27 divided by 3 is 9. 42 divided by 3 is 14. And we have our simplified expression. Okay? Just disregard this little movie bouncing. I'll take that in a moment. Example 2 you try, we would want to look here and see what is our greatest common factor. So what goes into 8 and 36? And I know that it's going to be 4. So I divide both of numerator and denominator by 4, and I'm going to get 2/9. For 28, the GCF of 28 and 49 is 7, so I'm going to divide numerator by 7, denominator by 7, and I get 4/7. So I have written this in reduced form, and just to double check, it says a number is in simplest form when its numerator and denominator are relatively prime. 4 and 7 are relatively prime. 2 and 9 relatively prime. So we're good. All right, last page. Mrs. Panza gives a test to 35 students. There's 28 A's on the test. Write a fraction in simplest form of the students who earned an A on their test. So out of 35, we have 28 scoring A's. So we want to divide both of these by 7. And again, the more you do this, the better you're going to get at doing it in your head. But we find that 4/5 scored an A. Okay, and we'll talk later about turning that into a percentage. Last part, simplifying variable expressions. So we have lots of monomials, 14ab squared over 21a squared b. First, you want to simplify your fractions. So we want to simplify 14 over 21, which is going to give me 2/3. Okay? Now I want to write these variables out. So that's times a times b times b. And this is a times b. Now we said before that if I have, like, say 5 over 5, that's the same as just 1. A number over itself is the same as 1. So same with a variable. A over a cancels out, that's just 1. B over b cancels out, that's just 1. And I get 2b over 3a. Let's try another one. Simplify 6 over 9. That's going to give me 2/3 again. And then write your variables out. A times a times a times b times c times c. All of that, divided by a times a times a times b. So this is why you want them in alphabetical order, because it's easy to say, oh, pair of a's, that's 1 over 1, a over a cancels out to be 1. Another pair of a's, another pair of a's, pair of b's. The only thing I'm left with are the c's, so I get 2c squared over 3.